Welcome to the second lecture of fifth module of this course, Game Theory and Economics. So, before we start this lecture, let me take you through what we have been discussing in this module. So, this is a module about extensive games. Extensive game is a part of this category of games called non-cooperative games. So, in extensive games, the thing that is different from the strategic games is that here the decisions are taken one after another. So, things are moving sequentially instead of simultaneously, and therefore, what becomes important is the structure of the sequences, how the people are moving one after another, and at each stage what are the actions that a particular player can take, that also becomes important. And typically it will be seen that as people move, their actions that are available to them, those actions also keep on changing. So, this is the basic difference of these games, which are known as extensive games, from simultaneous move games, which we have discussed before. We have seen in the previous lecture that in extensive form game or extensive game, there are basically 4 elements that are needed to be known if we want to pinpoint a particular game, and these 4 elements are the following. One is the set of players, 2 is the set of terminal histories. What are terminal histories? Well, terminal histories are sequences of actions, and in this set of terminal histories, the sequences must be such that no sequence should be a proper sub-history of any other sequence. If we have a proper sub-history, then it is not a terminal history, because that sequence is ending somewhere in between. It is not reaching the end of the game, it is not reaching the terminal. Thirdly, what we need to know is the player function. Basically what it means is that at each stage of any terminal history, if the terminal history is not ending, then I need to know which is the player who is going to move now, whose turn it is to move. And so, player function is defined over a proper sub-history. It is not defined over the complete terminal history, because if we have the complete terminal history, the game is ending, and if the game is ending, there is no other player to make a move. So, player function is defined over sub-history, proper sub-history, and notice that from these two informations, that is 2 and 3, we can find out what is the action set of a particular player at a particular stage, because so far we have not defined that important component of action sets, because if you remember, in strategic games, one of the 3 components, important components defining the game, was the set of actions. Here we are not talking about the set of actions, but what I claim is that from 2 and 3 we can figure out what is the set of action of a particular player at a particular stage, and it is done as the following. Suppose this H is a proper sub-history, suppose, and HA is suppose is also a history, and suppose this P is the player function, P of H is suppose I, which means after H has happened, it is now player I's turn to make a move. Then we say that the action set after H has happened, and who is the player who is making this action, who has these actions? It is it is I. His action set after H has happened is defined as A, where HA is a history. So, if I have the information that after H it is now player I's turn to move, and if I have the information that A is an action which happens after H and HA is a history, valid history, then action set of I after H has happened will consist of all such A's where HA is a history. And fourthly, which the important component of an extensive game, which was there in case of strategic game also, is the information about preferences, and these preferences are defined over terminal histories. So, after a game has reached its final conclusion, the players must be able to say how much they like that kind of that outcome after the game has reached its final outcome, and this outcome is nothing but a terminal history. All players who are involved with the game have taken their decisions, and we have reached a kind of finality. And if the game has reached its finality, people must be able to say whether how much they like that sort of outcome, and that is what we mean by preferences. So, these are the four important components of any extensive form game. They define an extensive form game. The important thing to note is that in the definition of terminal histories is what we said that is that it's a sequence of actions. Now, if it does not rule out the fact that this sequence can be an infinite sequence, so those things are included. In particular, if a game has the longest terminal history with the length which is finite, then we say that the game is finite horizon game. The length of the longest terminal history is finite. Okay. And so, if the length of the longest terminal history is not finite, if it is infinite, then the game will be called an infinite horizon game. Second point to note is that if the actions available to a player is infinite in number, okay, the action set is infinite, then then there is a problem. Then the kind of games that we have seen before, for example, we have talked about chess. For example, in chess, after every move by the rival any player has a finite number of moves. So, if a player has not infinite number of actions to choose from, but a finite number of actions to choose from, and if the horizon is also finite, then the game is called a finite game. So, finite horizon and actions that can be chosen are finite in number. So, if these two conditions are met, then we call that the game is a finite game. What could be the case where the actions could be infinite? For example, people can choose different prices, and that those prices can be within a particular range. For example, the prices could be between 20 rupees and 40 rupees. Now, between 20 and 40 there are infinite number of points. So, in that case the action set is not finite, it is an infinite set. In that case the game will not be called a finite game. We have also seen that a particular extensive game can be represented in terms of what is known as a game tree. In particular, we have seen that it is done as the following. Suppose we are talking about this entry game, then this is the challenger. He can take two sorts of actions, one is in, the other is out. If he chooses out, if he does not compete, then the game is ending there. So, we are reaching a terminal history. In that case, the challenger is getting 1, and there is this incumbent, his rival, who will get 2 in that case. If the challenger chooses in, then the game progresses further. If he chooses in, now it is the incumbent's turn to make a move, and he has two options. One is to fight with the challenger, and the other is not to fight, to accommodate. So, if fighting takes place, it is bad for both of them. We shall assume that it is 0-0. If accommodation takes place, then the challenger is benefited, he gets 2, incumbent gets 1, because he is basically being forced to share the market. So, this is worse than the case where the challenger stays out. So, this is how a game tree is drawn. Now, the obvious question to ask is, if this is how a game looks like, then what is the solution of a game, of a particular extensive game? How can we predict that this is the sequence of moves that will probably take place? What is going to be our prediction? So, by solution we mean what is the likely outcome of a particular game? What are the actions that will be taken? What is the terminal history that is going to come out of the game? So, if we examine the game carefully, it stands to reason that the solution of the game will be the following, that the challenger gets in and the incumbent does not fight, the incumbent accommodates. Why I am saying that this is going to be the solution? What is the rationale? The rationale is that the challenger is the first mover in this game, he is making the first move. Now, since the structure of the game is known to him, so this is an important point, the structure of the game, how the actions can be taken and what are the sequences of actions, those informations are known to everyone, both the challenger and the incumbent know them. Now, if the challenger knows the structure of the game, then he can figure out that if he gets in, then the incumbent will have to move and the incumbent will then look at fight, and if the incumbent looks at fight, he sees that he will get 0 in this case by fighting, whereas if he accommodates, he gets 1. And by the theory of rational choice, we know that this accommodation will have a preference over fighting, because 1 is greater than 0. So, by thinking, by putting himself in incumbent's position, the challenger can figure out that if he gets in, then the incumbent will accommodate, the incumbent will not fight. So, this is going to be the action of the incumbent by going by the theory of rational choice. Then for the challenger, the choice is really between 2 and 1, because if he gets in, the incumbent will accommodate, which means that the challenger by taking the action in will get 2, whereas if the challenger stays out, he is getting 1. So, again by going by the theory of rational choice, 2 is greater than 1, therefore, the challenger is going to get in, and if he gets in, the incumbent chooses accommodate. So, that is why I am saying that this in accommodate seems to be the solution of the game, and this sort of thinking from the last player's point of view, putting yourself in the shoes of the other player and thinking from his point of view, and then figuring out how the game will evolve from backwards from this point and going upwards, going in an upward direction. This is known as backward induction. So, in backward induction, the mover who is not making the last move puts himself in the shoes of the last mover and sees what is the optimal decision for the last mover, and by figuring it out, he goes backwards and then he calculates what is his optimal action. In this case, in is the optimal action. So, that is known as backward induction. We shall talk more about the backward induction in subsequent discussions, but there are some problems with this backward induction logic and how it can be applied. For example, if I change the numbers a little bit, suppose instead of 0 I have 1 here, then it is not very certain whether the incumbent will fight or accommodate, because the payoffs from both these actions are same. Therefore, the challenger will not be able to predict for sure what action the incumbent will take if the challenger gets in. So, in this case, backward induction does not have that predictive power. So, here backward induction fails to an extent. Backward induction also fails if, for example, the game is an infinite horizon game. There are the largest, the longest terminal history goes to infinity. In that case also there is no final stage, and if there is no final stage, how can you go backward? right. So, here the idea is that you start from the final stage and come backwards, but if there is no final stage, backward induction logic does not apply. So, that is again another problem of applying backward induction. And also suppose the players are unaware of the moves of the other player. In extensive game also, we can have such situations where for example, the incumbent and the challenger are not aware of each other's decisions and they take their decision, for example, simultaneously. And if they are taking their action simultaneously, then again you can figure out that it is not certain whether the incumbent will choose fight or accommodate. And again, so challenger is not able to predict which action will be taken by the incumbent, and therefore which action he himself will take. So, there are certain problems with backward inductions. There are certain situations in which it cannot give us some clear cut prediction. And therefore, what we shall do is that we shall start with the idea of Nash equilibrium, and from there we shall try to see what are the solutions that we can get, and we shall see that in Nash equilibrium, in case of extensive games, there are some weaknesses of that concept. It needs to be corrected a little bit, and from there we shall see that one of the ways in which it can be corrected is backward induction. So, Nash equilibrium is a more generalized concept, and from there we shall try to trace to backward induction. Now, if in an extensive game Nash equilibrium has to be defined, what first has to be defined is what is known as a strategy. Now, strategy is an important and a little complicated idea in extensive game. What it means is the following. Let me write the definition first, then I shall explain. So, this is the definition of a strategy. Now, what is important is that how is a strategy defined? A strategy is defined for a particular player. And how is it defined? The strategy of player I in an extensive game with perfect information is a function that assigns to each history H. So, it is defined for a player and over a history. after which it is player I's turn to move an action in AH, where A is the action set which is available after history H. So, H is there. From H I know by the player function that suppose it is player I's turn to move. From H I also know what is the action set, the set of actions which is available after H, and these actions are obviously available to player I. What a strategy will tell me is that which action, okay, suppose this action is A, will be played after this history H. Now, obviously player function we know is defined only over histories which are proper subhistories, where the game is not ending. So, this H that we are talking about here is a proper subhistory, it is not a terminal history. That is the first thing. And secondly, the games that we have seen before, just now we have talked about this entry game, there each player had just one history after which he moves. For example, here the challenger, suppose CH is moving, here the incumbent is moving. So, this challenger is moving after a particular subhistory. Which is the subhistory after which the challenger is moving? It is phi, right. Phi is also, the null set is also a subhistory. And which is the subhistory after which the incumbent is moving? The incumbent is moving after, suppose this INC incumbent, to distinguish it from the action in, and this is the action out. So, the incumbent is moving only after the subhistory in. So, there are, as I just said, that for each player there is just one subhistory after which he or she moves, and a particular player has to specify which is the action that he is going to take. So, in this case, if I have to specify a particular strategy of challenger, so in general small s will be used for a strategy and C for the challenger. It can be in, right. So, this is one strategy. He is saying that after null has happened, I will take the action in, but this is not the only strategy that he can take. He has another strategy which is out, all right. So, we shall say that this in out, which is S1C, S2C, this is the strategy set which we are denoting by capital S, and there is this subscript C, C for the challenger. So, this is how strategy set is defined. Within the strategy set there are different strategies. A particular strategy will tell me what is the action that player C is going to take after the history phi. Similarly, what about the incumbent? So, this is fight, this is accommodate, I am not writing the payoffs because they are not relevant that much here. Now, similarly, here the incumbent is moving only after one history, the history is in. So, I know the following: in is incumbent. Now, how many actions the incumbent has in his action set after in has happened. He has two actions, fight or accommodate. So, like before, like the case of challenger, his strategy set is the following. Let us call it S1 and S2 with the superscript 2. 1 minute, sorry, the convention is different. So, this is incumbent, the subscript is standing for the identity of the player and the superscript is denoting the number of the serial number of the strategy. So, how many strategies he has? He has two strategies, fight and accommodate. So, his strategy could be fight, so that is a strategy, or his strategy could be accommodate, so that is another strategy. But the point that I was trying to make is that it is not necessary that the players have just a single history after which it is his turn to move. Let me give you the following example. Suppose this is player 1, he has two actions, suppose x1, x2. If x1 happens, suppose it is player 2's turn to move, and suppose the actions are y1, y2, and then suppose again it is player 1's turn to move, and they are suppose z1 and z2. Okay. Now, what we are seeing here is that there are two histories after which it is player 1's turn to move, okay. And I can complicate the story further by putting 2 here, okay. So, these actions are suppose A1 and A2. So, the game is the following. In the first stage, player 1 moves. If player 1 takes the action A1, x1, then it is player 2's turn to move, and player 2 now has two actions to choose from, y1 and y2. If y2 is played by player 2, the game ends there is no further move. But if 2 takes the action y1, then again it is player 1's turn to move. So, this is from this side, from the left hand side. From the right hand side, if player 1 takes the action x2, player 2 has to move now, and player 2 has two actions to choose from, A1 and A2. Now, in this case, suppose I want to write the strategy set of player 1, then how will it look like? Now, here, unlike the case before, there are two histories after which, two sub histories after which player 1 gets to move. They are phi and the history x1, y1. So, these are the histories after which player 1 moves. So, a strategy must specify which are the actions the player 1 will take after these histories. So, that is what a strategy is. So, it can be x1. What does it mean? He is saying that after phi happens, I will take the action x1. But that is not the end of it. He also must specify what is the action he is going to take after x1, y1 has happened. Because if you remember, that assigns to each history h after which it is player i's turn to move an action in the set AH. So, now if x1 y1 is the history, he has to say which action he is going to take. So, it can be z1, that is possible. It could be x1 z2, right. He is saying that first I will take the action x1 and if x1 y1 happens, I will take the action z2, but that is not the end of it. He can also say that I will take x2, and interestingly, if x2 is the action that is taken by him, then also he has to mention what is the action that he is going to take if the history is x1 y1. So, he has to say of either this or this. So, this is the strategy set of player 1. Before I shall elaborate a little bit about this the last two strategies, but before that let me write down the strategy set of player 2. Strategy set of player 2 is more simple, and here also we will stick to the definition of strategy. What is a particular strategy? Now, like the case of player 1, player 2 gets to move after two histories. If the history is x1, he moves, or if the history is x2, again he moves. So, here also in each particular strategy of player 2, there must be two components. One should specify what the action of player 2 will be if the history is x1, and the second component will tell us what is the action of player 2 if the history is not x1 but x2. So, here also I have to combine these actions y1 y2 with this second set of actions a1 and a2. So, these are the strategies. Each of them is a possible strategy of player 2. And what is the interpretation? Let us take this y1 a2. Here player 2 is saying if x1 is the move by player 1, I will play y1. If player 1 is going to play x2, I am going to play a2. So, this is his strategy. Now, and similarly for other strategies, for example, y2 a2, here he is saying that if player 1 is taking the action a1, I will take the action y2. If player 1 takes the action x2, I shall take the action a2. Now, by looking at the strategy of player 2, it may appear that what is the strategy? It is a plan of action. He is just saying that after each contingency, what is the action that I will take. In particular, if he is not there, if he just writes down his strategy, suppose he writes down the strategy y2 a1 and on a piece of paper and gives it over to some other player, then that other player will be able to play according to the plan of player 2. So, player 2 need not necessarily be in the site of action to take the required decisions. So, in this sense it may appear the strategy is a plan of action. But what we are saying is that strategy is not merely a plan of action, it is more than that. Okay. And this fact that the strategy is more than a plan of action can be seen from this example. Here player 1 is saying that x2 z1 is my strategy. Now, what is x2 z1? Player 1, if he plays x2, then the game moves in this direction. So, there is no chance that the game comes here at this node, and if the game does not come here, there is no reason why player 1 is specifying that I shall play z1. So, if I had stuck to the definition the strategy is a plan of action, then there is no necessity for saying z1. I could have just said x2, that is the end of it, because I know that after x2 z1 there is no chance that z1 will be considered. But still I have to mention z1 or z2, because going by the definition, what is the definition? Is a function that assigns each history h, after which it is player i's turn to move an action in h. So, does not matter if x1 y1 this history happens or not, and in fact it is going to be ruled out if the action is x2. So, it is immaterial whether this history materializes, x1 y1 history materializes, that is immaterial. Player 1 has to mention what his action is going to be if x1 y1 is the history. So, this kind of strategy is entirely valid. In fact, that is what we have to specify, that after each possible history, after which it is i's turn to move, I has to tell us what his action is going to be. So, in that sense, strategy is more than a plan of action, it tells us more than that. But if one has to consider it, one has to visualize it, that I can understand that by going by the definition one has to specify z1 or z2 also, even if I am saying that x2 is going to be played. But what is the logic of it? I mean, why one has to mention the action after x1 y1 history? So, one way to rationalize it, one way to justify this kind of writing down of strategies could be the following, that player 1 is saying that I am going to take the action x2, and still he is saying what he is going to do after x1 and y1 happens, because he may make mistakes, there might be errors in his carrying out of the action. So, though he is saying that I am going to play x2, maybe he makes a mistake and plays x1, and if x1 is played, there is a chance that y1 will also be played. So, x1 y1 could be a history, and if that is a history, then one has to specify what his action is going to be after that history x1 y1, and that is why he is saying that look, z1 is going to be my action is if x1 y1 is the history. So, one way to justify or rationalize this sort of writing down of actions is that you might make mistakes, or it could be justified as the following. So, one is error, possible error. The other way to justify this sort of writing down of strategies is that players can make experiments. What we mean by this is the following, that player 1 is saying that okay, he is going to take this action x2, but from time to time he may take a chance and intentionally can do some experiment and play x1, and by this strategy therefore we mean that if he does an experiment, so we come to this second node and player 2 takes the action y1, then here if the game comes, then 1 is going to take this action, for example z1. So, these are the actions that the players are specifying in case of all possible contingencies, even if that contingency is still being ruled out by his own specification of actions here. So, that is it. We shall see that this idea that people are specifying their contingencies is going to be important when we develop the idea of Nash equilibrium in subsequent discussion, and also how the idea of Nash equilibrium is not so robust in case of extensive games, and one has to refine the idea of equilibrium in case of extensive games. One has to move away from the idea of Nash equilibrium. So, that is what is meant by a strategy. So, since this idea is important, the idea of strategy in extensive games, let me just once again very briefly go over it. Strategy for a particular player must tell us what his action is going to be after each history, after each possible sub history, after which it is his turn to move. So, it tells us the all possible contingencies. It may very well happen that those contingencies are basically ruled out by his own strategy. Those contingencies may not happen by the specification of his own strategy, but nevertheless one has to mention what the actions are going to be after all possible proper sub histories. So, this is the strategy, and now we talk about what is known as strategy profile. So, strategy profile is like an action profile. It is a list of strategies of different players. So, it is a collection of strategies of different players. In particular, I shall write it as small s, a particular strategy profile. It belongs to the set of strategy profiles which is capital S. So, small s could be like this. If there are n players, small n players, small s1 is the strategy of player 1, small s2 strategy of player 2, etc., etc. So, the last strategy is strategy of player n. So, this is a collection of strategies of different players, and this collection is being called a strategy profile. What is important to note is that if I have got a strategy profile, then basically I am tracing out a particular terminal history. So, a particular strategy profile will give me a definite terminal history. How is this possible? Let us take a particular example. For example, let us take this game. Suppose for player 1, I choose this strategy. Okay. And suppose for player 2 I choose this strategy, any two arbitrary strategies. So, S1 here is x1 z2 and S2 here is y2 a1. So, small s is this x1 z2 y2 a1. What I am claiming is that from this strategy profile I can trace out a particular terminal history. Let us see how it is happening. X1 and Z2. So, this is what player 1 strategy is, and player 2 is saying that Y2 A1. Now, if I combine this with this, what I get is this. So, that is a terminal history because the game is ending there. So, this is how from a particular strategy profile I am getting, I am tracing out a particular terminal history, and in this case it is giving me the terminal history x1 y2, all right, and this is also known as the outcome. Okay. So, outcome or O is a function of a particular strategy profile. All right. Now, so there are different stages of it. Each player has a strategy. By combining the strategy of all the players, we are getting a strategy profile, and from a strategy profile what we get is a terminal history, and that terminal history is also known as outcome, and we write it as O of S. O standing for outcome and small s standing for the strategy profile. Now, if I am getting a terminal history, then remember terminal histories also give me what is known as the preferences of the players, the payoff of the players. So, related to an outcome, one gets what is known as yi's for all I, right. So, so the thing is becoming more structured now. For each player I have a strategy, combining the strategies I get strategy profile. For each strategy profile I get a terminal history or an outcome, and from that outcome I get what is known as the payoff of each player from that outcome. I shall write it as OS. And these payoffs will be important because if we want to define Nash equilibrium, what is important is that players compare between different payoffs and they choose that decision which maximizes their payoff. So, one has to do some kind of optimization, and to do that optimization this idea of payoff has to be brought in somehow. So, now before we end this lecture, just a little bit discussion about the Nash equilibrium therefore. So, Nash equilibrium in extensive form game now can be defined as the following, that it is defined over the set of strategy profiles, and each player will like to choose that strategy such that the resulting strategy profile gives him the maximum possible payoff given what are the strategies chosen by the other players, right. Given the strategies chosen by other players, my strategy should give me the maximum payoff. So, that is the idea which we are going to develop in the next class, because we have a more structured story now. We know that there are players, they are going to choose their strategies. Depending on the strategies, there is a strategy profile. From a strategy profile, we get a history, terminal history, and from the terminal history, I know what is the payoff that I am going to get. So, by moving around with my strategies, I am going to maximize my payoff, and this happens for every player, and therefore, we can apply the idea of Nash equilibrium. So, this is what we are going to do in the next class. Thank you. What is strategy in extensive games? Give an example. So, what is a strategy? A strategy belongs to a player. So, a player's strategy, what does it say? It specifies the action she would take for every history after which it is her turn to take an action. So, for each player he should specify if after some non-terminal history he has to make a move, what move he will make. So, suppose H is a non-terminal history and suppose PH is equal to I, and suppose AH is the set of actions after history H has happened, then strategy of I should include an element from AH. So, he should say after H has happened what action he will play, taking that action from this set AH. So, let us give an example. Let us take the example of a batsman and a bowler. So, one is the bowler, he can bowl a fast ball or a slow ball. Player 2 is the batsman, he can play short 1 or short 2. Now, what are the strategies of player 2? Player 2 has 4 possible strategies. Okay. So, which are the strategies? It can be S1, S1, which means he is saying that if F occurs, I will play S1, if S occurs, then I will play S1, or it can be S1, S2. Here he is saying that if F occurs, I am going to play S1, but if S occurs, I am going to play S2. So, likewise, we have other 2 strategies. So, there are 4 possible strategies. How an outcome is defined? What is the definition of Nash equilibrium in extensive games with perfect information? So, first, what is an outcome? Okay.
So, given strategy of each player, we get a strategy profile, basically which is a combination of all the strategies of all the players. Now, from a strategy profile, one gets a unique terminal history, because in a strategy profile every player is specifying I am going to play this, I am going to play that, and depending on that plan of action we can trace out a unique terminal history. This terminal history is the outcome of the strategy profile. So, it is written as OS. S is the strategy profile, O stands for outcome. Okay. Now, the second part of the question was, what is the definition of Nash equilibrium in extensive games with perfect information? Okay, Nash equilibrium. S star strategy profile is Nash equilibrium if the following condition is satisfied: if for every player I, UI So, here S star is a specific strategy profile. From that strategy profile we are getting OS star outcome, and from that player I is getting UI OS star. This payoff must be either greater than or equal to the payoff if player I deviates and chooses something aside from his set of strategies. This deviation is not beneficial for him. It can give him either equal payoff or less payoff. Thank you.